All right, so I'm checking all of my classes this week to see if y'all are doing what I'm telling you. And I forgot how many's in this class, 12 or 15, something like that. We got 11 people that are in the system. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's go and look up and see how many people's in the class so we can make fun of the losers, the students that haven't done what they're supposed to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we got 3 people who's had dead grandmas, caught dogs sick. Let's see, what else? Got 5 flat tires. What else? What else is there? Huh? Computer crashed and lost their access code and don't have a phone to call to get access code, and the bathroom doesn't work. What else? What else y'all come up with? Y'all come up with some good ones. Let's go ahead and do this. Aracho, Barnes, Clark is here, Crittenden's here, Fisher, Fuller's here, Hammett, Keller's not here, Lovin, Mitchell, Simmons is here, Stores, Sullivan, and Weber. Okay, so we got 3 losers in the class, and we're fixing to start today. So if we're fixing to start 8.1 today, then what homework should y'all work on tonight? No, work on 1.2. Yeah, work on 7.6. That's what I'll get somebody tonight. Are we supposed to start homework? Nope. I have no earthly idea. So here we go. Which one is it? There we go. I think that's it. No, that's not it. It's the first time I've used these. I usually don't use these very much, but ain't no sense in not using them. Trigonometric functions. No, that's the wrong one. That's not the right one. It's supposed to be the first one. Is that it? Yeah. 8.1. There we go. Now, you can follow along in your book if you want to, or you can just take notes, either one. But trigonometric functions and applications, we start with first the triangle. And what is a triangle? It's made up of line or line segments. Now, one of the things about trig that people don't realize is that it's all about the triangle. All right? It's all about the world of triangles. And triangle basically comes from the circle. I guess you can see it basically right out here. Okay, that's where it comes from. And the study of trigonometry actually comes from geometry, which is the study of all shapes, but the triangle focuses on the radii of 2 sides, which is the radius of the circle. And I'm not going to spend a lot of time going over the lines because that's a little bit elementary for this class, but so somebody that, I think there's 3 students in here that hadn't had trig in a couple of years or something like that, you might want to refresh on some of those definitions of a line segment, and also think this is 2-dimensional, but what if you add the 3rd dimension? If you add the 3rd dimension, then you're basically talking about 2 window panes or 2 glass panes. I like to say glass, but if you think of 2 glass panes, and I really suck at drawing, so Shut up. There. Okay, you got a red window pane and a black window pane, and they're basically crossing. Well, what is produced in the third dimension, this is a three-dimensional drawing, where they cross is the intersection of two planes. It's called a line. And then if you look at it from this direction, it's a point. Because you can't see the depth of the line because you look at it from this direction. You look at it from this direction, you see a line. Okay, and you look at it from a three-dimensional direction, it's the intersection of two planes. Now, you take that line, which is this line right here, and you orient it to, say, like north arrow, and then of course you get your degrees, which is usually theta. Okay, and that's where all of it comes together. So when you think of a line or line segment, don't think of it as just a two-dimensional line. Think of it as a three-dimensional intersection, because that's basically what it is. Okay? And when you get to Calc 2, you're going to do nothing but study three-dimensional space. In Calc 3, that's all you do. You don't get a break from the third dimension in Calc 3. Okay? So that's a little bit of review. Degree measure. Remember, there's 360 degrees in a circle, 60 minutes, 60 seconds in a minute, and 60 minutes in a degree. I'm trying to get this thing to work. I'm not. Hey, why ain't it working? Okay. There it is. 360 degrees in one rotation. An acute angle is between 0 and 90. Make sure you write these down because you're going to see them on standardized testing, whether it's a GRE or a Praxis or a TEAS, you're going to see it. Right angle, acute angle, and obtuse. Straight angle is 180 degrees. Think of a pocket knife, opening up a pocket knife. That's 180 degrees. Obtuse angle would be like your laptop. If you got one of those cheap laptops or old laptops, it won't open, but right here, anything below that makes a acute angle. Now they open up 180. Well, that's more than 180. So that's an obtuse angle. Okay? Or more than 90, sorry. Obtuse angle. When you got 180, pocket knife. So again, review questions. Shouldn't have to go over that too much. Complementary and supplementary. Again, basically review and questions that'll be on standardized test. So write those down. I don't, until I start getting homework questions from y'all, I don't know anything about y'all, except for one or two students that I've had in 110. I don't know who knows what. So right now the room is dark and I'm kind of feeling my way through it. Starts lightening up when y'all start sending me homework questions. And then I start to feel like what you know and what you don't know. If you ever have a question about anything before, like if you have a question about anything before what I'm covering, go ahead and ask it. Like anything about algebra, anything about introductory to trig, anything like that. If you always had a burning question or a question that's never made sense to you, or something that's never made sense to you, go ahead and ask it now before I get into 3 or 4 sections. Okay. Complementary is 90 degrees. Here's your complementary angle right here. Makes up 90 degrees. So if you're asked for 2 angles, then add those 2 angles, and it's equal to 90 degrees. Supplementary is 180 degrees. Same concept, same methodology, you just add them up, but instead of equal to 90 degrees, equal to 180. These are two very popular standardized definitions and two popular questions that are asked on a standardized test. Basic algebra. It's more geometry and algebra more than it is trig. Okay? Question on these. Hopefully you get them no problem. Here we go. 1 minute is made up of 60 seconds. 1 second, a second is, a degree is 60 minutes. A minute is 60 seconds. Thank you. All right, you need to write that down. They write it about as complicated as you could write it. I think you just need to write this. Write that. 1 minute. Still, no, that's not right. Do that. 1 minute equals 1 minute. 1 degree is equal to 60 minutes, and then 1 minute is equal to 60 seconds. Now that's going to come in handy when you're switching over from decimal degrees to regular degrees, which nobody ever does in the real world. Nobody uses decimal degrees in the real world. Nobody uses radians in the real world. The only thing people use in the real world is degrees, minutes, and seconds. Now, do you remember when you learned how to borrow and you learned how to take a number and add it to another number because you were over 10 when you were adding? Remember doing those? Okay, you got to use the same concept when you're adding and subtracting degrees, minutes, and seconds. All right? If you get over 60 degrees or 60 minutes or 60 seconds, you have to bump the next one up to, well, you have to bump degree up to another degree, or you have to bump the minute up to the next minute. This one, they'll show you how to do it, but basically it's just adding. I'm not going to make a big deal out of this. Just add the two together. But see that 75? You can't have 75 minutes. So you bump it up to 84 degrees, 15 minutes. Okay? You might want to make a note of that because some of you may be a little bit rusty on that. So if you take a 51 degree, like 51 degrees southwest, northeast, and 32 degrees northwest, add them together, the angle between them, no coughing please, the angle between them is 83 degrees, 75 minutes. Well, that's not real, Hubert, because you can't turn 75 minutes. So you have to change it to 84 degrees, 15 minutes. Again, that's right on the edge of review/trig. So if you got a question about it, go ahead and ask it, because we're starting to leave some of the review stuff and starting to get into a little bit of the trig now. Okay, this is where I really detest this part, because this and radians, because it's ridiculous. You don't even have to do them. There's nowhere in the real world, period, I can tell you this from experience, that you ever use decimal degrees. Never. But anyway, in science and math we do, so you have to learn how to do it. And when you do it with, you got to divide the 8 by 60 and the 14 by 60. And that's how you get it. But they'll show you how to do it right here. If I can remember to. Okay, am I missing something? Same thing I did a while ago. Okay, so you're going to divide by 60. And that's how you do it. Take the 8, divide by 60, and then you're going to take the 14 and divide by 60 again, which will be 3,600, divide by 3,600, and then you add those three together. Now, if I'm going to test you on A or B, I'm going to test you on B more than I am A. Because, like I said, that's what you use in the real world. I might give you 1 A versus 3 B's on the test. So you might want to make that note. If you're going to learn one of them, learn B. And there's how you do B. You do it the opposite. You multiply by 60, and then you multiply by 60. Not 3,600 this time. You just multiply the first by 60, and then whatever's left, you multiply that by 60. Whatever's left, the remainder. Look, you got 34.817. You multiply 0.817 times 60. Boom, you get a number. All right, you can only fill 2 slots. So you take those 2 slots, what did it come out to be? 49.02. So you take that 49 and you put that in the slot for degrees, because you only got 2 slots, 4 and 9. Then you take what's left over, the remainder, 0.02, and you multiply that by 60. And then that's your seconds. Now, this is ridiculous. 1.2 seconds is ridiculous. There is no way on Earth that you're going to be able to measure 0.2 seconds in the real world. So that answer would be 34 degrees, 49 minutes, 1 second. Now, academia, you put 1.2 seconds. I'll take either answer. I'll take 1 second or 1.2. Okay? So if you get a mix up on the directions and you put 1 second and it's supposed to be 1.2, I'll take it, because the 1.2, the 0.2 is irrelevant. You couldn't even use it in the real world even if you tried. Because there's not a theodolite, there's not a transit made that will go to 1/10 of a second. Capiche? So this is the one you need to learn how to do, because if I'm going to test you, this is the one I'm going to test you on. And of course, you're talking about an angle that looks, that's another thing. They do totally backwards in academia. They turn this way. In the real world, if you're turning a theodolite or a transit, you turn this way. Don't ask me, I don't know. And the quadrants are backwards also. So I'm just telling you, there's a lot of things that you learn in academia that in real life is totally opposite. But you're talking about a 35-degree angle, which is, let's see, that's 30 degrees, something like that. No, 35 degrees. Okay. Okay, so far, is everything okay? I'm not going too fast, not going too slow. I'm probably going too slow for some of you. I realize that, but I also realize I've got 2 or 3 people in here that haven't had trig in a couple of years. So, any complaints so far? Ms. Fuller, you still with me? She's asleep. She probably doesn't.
Yeah.
We're back to bed. All right, next one. Oh, I heard her moving around. Now, everybody get your graphing calculator out. Oops. Wait a minute, I'm going the wrong way. There we go. If you don't have a graphing calculator, then you need to run around in circles and try to go out and find one right now. Right? That's what you're supposed to do, handy students. That's what you're supposed to do, aren't you? Run around in circles and freak out. Okay, y'all aren't going to talk to me. That's fine. Just make the class go 10 times slower. All right, so what do we have? 34, I'm just going to make up one. 34 degrees. Now, this is a pain. It's easier if you get a TI 30 or a Casio that has the degrees, minutes, and seconds button already on it. But that's just something that you use on the first one, the first unit test in here. You're not going to use it after that, but it's up to you. 34, math, and numbers. Where is it? I can't remember where it is. I think it's on this one. Oh shoot, I don't forget where it is. Give me a second. Angle. No, that's not it. Oh well. I'll think of it in a minute. Anybody remember, let me know. It should be. I thought it was in here. You see how much I use the calculator, don't you? Make sure it's in degree mode. It's not. There. There. Now math. See if it's in there. Well, I'm looking in the wrong place. It's somewhere. And there's a degree button. Huh. Nope. What is that? I can't believe I just forgot it. It's in math somewhere and I'm not finding it right now. So you type in 34 degrees, minutes, and seconds, and right now I can't think about, okay, hold on. Second angle. There it is. Second function apps. So 34 degrees. So second function apps degrees. 23 apps minutes. And 2 seconds. I think seconds is in here somewhere. Or it just knows it's seconds, but there's a quotation mark somewhere on here. I don't know where they are, but I don't think it's I'll see how much I use calculator. Plus 22 degrees, second apps. There, degrees, 20 minutes, second app, minutes, and I'm going to leave 0 seconds, and you hit enter, and that should be 56:43:02. Y'all check me, and of course it didn't do it. Because I can't find the degree. Y'all look on y'all's. I can't see on this one very well. Somewhere on there's a quotation marks. Do y'all see it somewhere on y'all's? It's on there. It's on the second. Is it second 7? Is that it? What? Well, it's on there somewhere. And I can't see it right now, but that's what you're supposed to hit, that one. I don't see it. Huh? Well, it's on there because that's why it's not on the second apps. Second apps. Yeah, it's not on there. It's on here somewhere, and I can't find it. And make this thing where you can't always see. Well, let's see what the PowerPoint says, because my failure to use the calculator They just say, okay, they do it the easy way. They just put it in and let's say 75.8. They just do it that they just divide with the degrees, and then they use degrees, minutes, and seconds when you go in the other way. That's what they're showing you. So you take 13, multiply 0.1372222, multiply that by 60, and that would be divide 8, 14, yeah, divide 8 by 60 and 14 by 3600, and that'll give you that. And here you take 0.817, multiply that by 60, and that'd be 49, and then you take what's left over and multiply by 60, and that would be the 1.2. So be looking for that quotation mark because I can't. You find it? Right under the plus sign. That look at that. That looks like an 11. Look at that. Does that look like a quotation mark to y'all? Good gracious. No wonder it's Russian. That's what it is. It is. It's Russian. Now I got to redo it. I'm not redoing it. Y'all can do it. Okay?
I mean, I have that answer.
Okay. It should be what I say it was. 5643.02. Is it 5643.02?
Oh, I see. No, I see what I did. I only did the top row. You see, I got 34.38, blah, blah, but I only did 34.2302.
Yeah, and if you go in the other direction, and see, that's why, see how aggravating it is? 23 degrees, second app degrees, 20 minutes, second apps degrees, and 30 seconds, sec alpha. There we go. Thank you. And hit second apps, change into degrees, minutes, seconds, and hit enter. Or degrees, minutes, and seconds, and hit enter. I thought I did it. Did I not? What did I do wrong? Oh, I'm doing it bass backwards. 23.17 second apps, degrees, minutes, seconds. There. Now, the reason I suck at this is because you don't have to do that in real life. Everything in real life is done in degrees, minutes, and seconds. Okay? So make sure you can do that, but the only reason you need to do that is because of the book. Make sure you use your calculator. Make sure you can go between degrees, minutes, and seconds, and decimal to degrees, minutes, seconds, and decimal degrees, minutes, seconds to decimal. I really don't care about this kind of stuff. Stuff I care about is whether you can calculate angles. That's what I care about. Okay? So we're going to move on. If I can move on. If I can figure out why this PowerPoint is not moving. Oh, that's not what I turned on. There we go. Quadrangles. Quadrangles are when the initial side is on one of the directions. Make sure you know your quadrants. Again, in the real world, it goes the opposite way. Northeast is 1, southeast is 2, southwest is 3, northeast is 4. But in academia, it's the opposite. Make sure you understand that the first quadrant is the northeast quadrant. That's the only thing that both the world and academia agree on. Is the first quadrant is northeast. The second quadrant is northwest, which makes me cringe to say because I grew up knowing southeast is 2. So anyway, make sure you know those quadrants. Make sure you know how many degrees. Now, this is very important right here because some of you, when we get to the reference angles, some of you forget this right here. And y'all get kind of fuzzy on this. So you need to remember this, okay? 0 to 90 degrees, right there. 0 to 180 is right there. But this quadrant is 90 to 180. And you need to remember these because these are very important when we get to the reference angles. Okay? Okay. Another thing of academia is the going around 830 degrees. Is there a 830 degrees in the real world? No, never. Never will you come up on an architecture plan. Never will you come up on engineering plans. Never will you come up on surveying plans that say 830 degrees. Never. Okay, so I'm just telling you. Now, in academia, they want you to be able to discern between a regular angle between 0 and 360 and a coterminal angle, which is umpteen degrees. And all you have to do is subtract 360 from it until you can't. And then you find it. All right? So, 360. You know it'll go around twice, right? Okay, so 360 times 2 is 720. So you subtract 720 from 830, and what do you get? 110. Remember? That's right, class. So your angle is 110 degrees. So you might want to write that down. The way that you find a real angle from a coterminal angle is you subtract how many turns, the number of turns times 360. You subtract that, and that will give you your original angle. Okay? So what I did is I said 2 times 360, which is 720, 830, minus 720 is 110. And 110 degrees right here is your original angle. Well, the first one, 420, well, that's not, you can only subtract 360 one time. So 420 minus 360 is 60 degrees. That one's not as bad. But you never will, and put a $100 bill on it, you never will see 420 and 830 degrees in the real world. Never. Yeah, but this doesn't exist. Okay? So make sure you can find those angles, make sure you know your quadrants, and make sure you know what those quadrants represent. Now we're starting to get into a little bit of the trick. We ain't there yet. Maybe after this slide we'll start getting into it. Okay, got to go back and do it again. I have to do it like 3 times. Find the angles of the smallest positive coterminal with each angle. So why don't you do those? Draw them out. You don't have to draw them out, but basically subtract 360 however many times you can from both of them, or figure out what the other one is. Negative 75 means you're turning not up, but down, which is the opposite in the real world. But negative 75 would be in the 4th quadrant, and then you need to find what the other angle is. I'll show you in just a second. We'll go ahead and work on that, especially that first one, 908 degrees. I have got to stop putting this phone on silent. Got two people I think went to Skype in and I wouldn't hear them. And Miss Fuller did, I got her, but the other one took. She already gone offline. We should pull back up in just a second. I think that. Try again. She done gave up. I'm going to follow back in a minute. Okay, so first of all, what's 360?
Message coming in on secured channel.
Hold on just a second. She's not online, but she says she's at the top. I hope she's on the right thing because she says she's offline. I'm sure she's got Skype for Business. I don't know why. I hope she's trying not to do it on Skype. It has to be Skype for Business. Wait till she. But anyway, 360 is too much. 360 times 3 is too much. That'd be 1080, right? So it'd be 360 times 2, which is 720. 720 from 908. Well, 720 be 188, something like that. 188, yeah. So you should have 188 degrees. This one's pretty simple because you're 75 degrees down. That means the complement of 75 degrees to 360 is what? 285. You just subtract it from 360. Draw a picture, okay? This is where it kind of helps to draw a picture, and we're starting to draw pictures, so chances are from here on out it might be easier for you to draw a picture. When you're dealing with a problem like this, the best thing for you to do is draw a picture. Now on this one, you don't have to go 908 degrees. You just have to think about it, all right? There's 360, there's 720, and then 720 plus 100 is 820. So it's going to be over here, and that's because there are 180 degrees somewhere in there because it's not quite 200. So it's over here somewhere. So you know your angle is somewhere over here. And it comes out to be 908 minus 720. And whatever that answer is your answer. And I think it might be 188. Whereas this side, when you draw the picture, you actually see that the angle is part of 360. Okay, not a repetition of 360. So all you need is the complement, which is this right here. And the complement 360 from 75 is, I have no idea, at least 180, so it's 200 and something. What is it? 285. Oops. Whatever. 285.
So do you ever see a negative number that is smaller than 60?
And you'll never see a negative angle in the real world. It's always positive. Capiche? On a scale from 1 to 10, you're probably talking about 1 or 2 questions on the test with this. 1 or 2. Not very many. 80% of your test is going to come from the actual trig, which when I get to the actual trig, I'll tell you. Okay? Evidently, okay, it's got to be blue. That's for me to, okay, that's what it has to do. Okay, it's got to be blue. Okay, here's one of the biggest things that, like I say, I don't really care about it. All right, but you need to write it down for your personal knowledge. For standardized testing, you need to write it down. And that is an angle with a vertex has 1 radian where 1 and 1 and 1 are equal. Okay? Now that is the arc length is equal to 1, not the chord, which chord is the straight line between the 2 points on the curve. But anyway, right down the bottom, this is the most important thing right here. And it's one of those things that if you don't memorize it, you might as well drop the class. It's right there. Write that down, star it, highlight it, memorize it before you come back to class. Okay, because if you don't, you're going to already start getting behind. So we are starting trig now. This is where we're actually starting trig. 360 equals 2 pi radians. Now, a lot of people say, well, what do we use radians for? Absolutely nothing.
Priority 1 message coming in on secured channel.
She's up now. Let me check, see if she's... I'm sorry, I would do this for y'all, so y'all just bear with me. She did what she was supposed to. I just didn't see her text. What am I doing? There she is. After she comes in. Hey, Miss Mitchell.
Hey.
Can you see my desktop?
I can now.
Okay, good. All right, we're in 8.1. You'll have to refer to the video I put up today to see the before where you're at right now. So just do that. I'm sorry for messing you up.
It's okay.
Okay, and I just told everybody that they need to highlight and memorize this right here. Now,
Okay.
that's the only part, technically, I'm going to make y'all memorize. I just talked to a parent of a high school student that's freaking out because they can't remember all the radians. I said, you don't have to remember all the radians. All you have to remember is the special triangles. What are the special triangles? 0, 30, 60, or 45, and 60. Once you remember those, the rest you can just make up as you go. In other words, you can do it in your head. You don't have to memorize it. I cannot stand to see people memorize trig because it doesn't help you when you get to calculus. You've got to understand what you're doing, not memorize it. Okay? But this part right here, you have to memorize that 1 revolution is 2 pi radians. Now, as I was saying, you don't use radians. I don't think there's ever been an out of academia instance to where I've seen a radian. And I've seen a lot of engineering plans. I've seen a lot of highway plans, drainage management. I've seen a lot of plans. I've never seen a radian. And why do people use it? It's academia. That's why. All right. So you need to learn how to change things into what? Degrees. So pi is equal to, find out pi radians. Just remember that you want to cancel. If you've got radians, pi is in it, pi will be in the denominator. Okay, so that'd be 180 over pi. If you're changing from radians to whatever, it's pi over 180. 180 over pi, pi over 180, depending on what you're trying to get rid of. All right? And you'll see that in just a minute. There we go. They took the words right out of my mouth. You might want to write that down, but if you're converting from degrees to radians, it's pi over 180. If you're from radians to degrees, 180 over pi. But I've got a much easier way for you to remember that. Just put your whatever you're converting over 1 and make sure you can cancel out whatever you need to cancel out. And when I show you, you'll understand what I'm talking about. All right, look at this right now, pi over 180. Now why I don't, hold on. Where did, I'm impressing y'all with my feet. I'm trying to impress y'all. All right, so it says multiply degree measure by 180 over pi. Pi over 180. The first thing you do is you write it down and you say, okay, I want to change 180 pi over 180, 45 degrees. All right, I want to change, this is degrees, so I want to go from degrees to radians. Well, that's 45 degrees over 1. So how do I get degrees to cancel? Put it on the bottom. So 180 degrees go right here, and pi goes right there. So the degrees cancel out, and you don't have to memorize anything. All you got to remember is what to cancel. That's cancel diagonally. Okay? So 45 pi, 45 over 180, 45 pi over 180, and you need to reduce. And you can reduce however you want to reduce. Now we're getting into the trig. Now, if you're saying to yourself, I really don't understand what you just did, don't worry. You will by the time we do 5 or 6 of these, which these are going to be on your test. So now we're getting into the stuff that's going to be on your test. You might have a section of maybe 5 or 6 questions that might deal with the stuff we just covered, like, you know, finding an angle, finding a reference angle, adding 2 angles together. You're talking about 5 questions out of 20, or 5 questions out of 25. Now we're starting the actual questions you're going to see a lot of on the test. Okay, let me get rid of this. multiply radian, so 4 pi. Multiply 4 pi, that's radians, over 1. First thing I'm going to do, 180 over what? Why I put pi on the bottom? Because I want it to what? See, that's all you have to remember. It's either going to be pi over 180 or 180 over pi. Do not sit there and go, from degrees to radians, you've got to do pi over 180, and you drive yourself crazy. Just remember, cancel out. You got to cancel out diagonally, and then that tells you what goes on the bottom. Okay, what goes on the bottom. 180 is in degrees. When you need to add a little degree thing, that's fine. So you're in the first one. I need 180 on the bottom because it had the degree symbol in it. So the degrees cancel out, and left is pi. Here, you just multiply 4 times 180, and I have no idea what that is. 560, 540, what is it? Huh? 520, 820, what is it? 720. Because pi is canceled. Here, the degrees cancel.
Priority 1 message coming in on secured channel.
Okay? That's why I don't leave my phone on. It's so loud, and I've got it turned down to about nothing. Make sure it's not somebody else. Nope. That's my daughter needing money. Can you put some money on my card? No. Get a job. No. Get a job. Lose it. No, she's got to get a job. See what she says. Okay, so next one. Did we get 4 or 5, or did we miss? Oh, they did something else. Okay. And here's how you do it in the calculator. 249.8 degrees. Put it in radian mode. And then type in the degrees and hit enter. But then what's going to happen when you need to do a degree question? You're going to forget. So, you know, if you want to play on your calculator, that's fine. I don't like the calculator. I don't use it very much. I only use it when I have to. Now here is the basis. This is the foundation of trigonometry right here. So you need to write this down. You don't have to write down the chart. Just write down this. So take you a sheet of paper and draw you the biggest circle that you can draw on that piece of paper. Divide it into 4 sections. Okay? And you got your 3 special angles. 30 degree, 45, and 60. And draw it in that first quadrant. Now, I want everybody to go through this. I want everybody to write it because I want you to see how you actually can construct the unit circle and not have to memorize the whole thing. Because how many times have you sat in trig class or whatever you had in high school and they told you, take this unit circle home and memorize it? You remember?
Priority 1 message coming in on secured channel.
Let's see. I am a loser. Forget it. Okay. There. On plenty of ditches. I know, I saw that. I think they need to send some of Black Lives Matter and Antifa out there to. Oh yeah, that's right. They're getting paid by George Soros. I'm sorry. I don't know what I was thinking. I am glad to see them people out there helping each other and ain't beating up to each other. And I saw where the National Guard said if there's going to be looting in Texas, guess what? Shoot on sight. I agree with that 100%. I bet you there won't be any looting out there. What do y'all think?
There is already.
No, I bet you there won't be.
Oh, I just read an article. Apparently the Louisiana Navy went down there to help rescue some people, and some looters who were pretending to be people in distress, tried to get them to bring their boats around and then shot at them, and they brought the boats close enough.
I'm sorry, but you got to be awfully brave to go into Texas and have Cajun Navy come to you and you try to steal their guns or you try to shoot at them. There's still people in Louisiana and Texas that believe in hangings. Huh? I know.
It's also legal.
I know. I'd like to have one, but I just don't want to put up with it.
I was watching this and that's probably
Priority 1 message coming in on secure
Texas got
channel.
Expressway. I saw that same thing. Here's how you remember it. You just got to remember 3 angles. 30, 45, 60, and then of course 90. And you say 90 right here, 0, 30, 45, and 60. And now you just remember 30 is degrees, right? So 30 degrees over 1 multiplied by 180. And what happens to the degrees? And you're left with 2 zeros that can cancel. And 3 will go into 18. How many times? I believe that's
Priority 1 message coming in on secured channel.
See how easy that is? And then you just do it for the rest of it. Now, right here, 60, 45, 30. Now you can do this 2 ways. What is 180? Because this is 180 over here. What's 180 minus 30? 150, Hubert. That's right, class. What's 90 plus 45? Or 180 minus 45? 135. What's 90 or 180 minus 60? 180 minus 60? No, that's not right. Yeah, 180 minus 60 is 120. I was thinking 130, I'm sorry. Okay? Y'all right. Now, oh no, I don't know what 120 is. Well, 120 degrees over 1 degrees, 180, pi, zeros cancel. What's 12 over 18? Huh? Well, that's the 12 and 18. What can that reduce down to? Huh? 2/3. Well, that's 2 pi over 3. So you don't have to memorize the unit circle. All you got to know is how to reduce. Let's go down here. We know this is 270, right? Now this one right here, that'd be 60 degrees. That'd be 45, and that'd be 30. What's 180 plus 30? Okay. What's 180 plus 45? What's 270 minus 60? I'm sorry, the other way, 30. What's 270 minus 30? Go over here. This is also 360. What's 360 minus 30? Okay, what's 360 minus 45? 325 or 315? Check me. 315. And what's 270 plus 30? Well, let's say you need 300. 300 degrees over 180. Those cancel. Those cancel. 30 over 18. I know 30 is 2. That'd be 5 pi over 9. No, that's 3 pi over 9. Which would be pi over. However it reduces. What would it be? Pi over what? 5 pi over 3. So I'll check them. The point is, I guarantee you somebody in here is saying, oh, we have to memorize that whole unit circle. You don't. All you have to memorize is that first quadrant. And you don't even have to memorize it. All you got to remember is 30, 45, and 60. Now, after you write the unit circle about 4 or 5 times, what's going to happen? You're going to learn it. It's easier to understand something and learn it than it is to memorize it and learn it. Does that make sense? Everybody's supposed to say yeah, but that's okay. Thank you. Yeah, there you go. Sure thing, Your Majesty would be good too. Yeah, whatever. Yeah, don't push it. Questions so far? We've got a few minutes. What time's class over? 12:35, right? So y'all don't need to be like packing up or anything.
Rude. I was just putting my book up at history.
Length S. Here we go. Write this down. The length S. The arc length. Write that down. Arc length. Now this is a standardized test question. It is a question that you're going to see first unit of Calc 1. First unit test. So you might as well get used to it. Multiply the R, radius, times theta. In radians. In radians. Now remember, most of calculus is academia. Okay? So most of the time your stuff is going to be done in radians. So what is the arc length? The arc length is the same thing as the length of the curve. In transportation engineering, when you're trying to find the length of a curve of the highway, that's what you're finding, the arc length. And you multiply the pi times radius, but you use something else because you have to take into effect the steepness of the curve, whether it's a vertical curve or horizontal curve, has to be done a little bit different. But anyway, the whole point is it's based on this. If you're trying to measure, and let me show you what I'm trying to, I'll show you. Here's the circle. Here's the radius. Let's say this radius is 2. So I got to make this radius 2, because they're equal. And this chord right here is 2. Okay? The chord is the straight line between the 2 points on the curve. This is the actual curve. In real life, it's called a curve. In academia, it's called arc length. Yeah, arc. And this is called the chord. Okay? So that's what you're trying to find. You're trying to find this length right here. Okay, I've got a common sense question for you. Is the arc length always going to be more or less than the radii or the chord? Good. Why? Why? Because the shortest point between the shortest distance between 2 points is a what? Straight line. So this one's always going to be shorter than this one. Always. So if you're doing a problem and you got 2 here and this is pi over 4, whatever, okay? Then you're going to get 2 times pi over 4. If you come out with 1.86, then you know what's wrong. Because this length will always be longer. Always. They're probably going to do an example on the next page. So I hate introducing stuff. I like going over homework problems a whole lot better. I don't like these PowerPoints, I can tell you that. Okay, here we go. See if you can do it. If you can't, then consider yourself a failure. I don't blame you. Just quit. Drop slips, you just go online and drop. Good. See you later. You know we can do 8.1 homework now, right? Okay, good. You're supposed to ask when's due. Oh yeah, that's right. All right, so you got a circle. Let's see, handy dandy circle maker. Y'all are impressed, aren't you? And we're gonna move that circle over here. And you got a radius, straight line maker, of, oops, still on, I suck. I thought I hit straight line. There it is. I don't suck that. No, somebody's riding by in their $1,000 car with $10,000 worth of audio equipment in it.
Incoming message.
About as bad as a guy with the pickup truck with the smokestacks on it.
Or we got a pickup truck that has a train on it.
Has a what?
Train on it. I'm not even joking. There's someone who lives in our apartment complex who will roll up and they have a freaking train on it. I don't even know how you do that.
It's called insecurity. Individual insecurities is what it's called. There's usually 3 things. Either it's their hair, they don't have any, vertically challenged, and we'll talk about that. It's usually one of those 3 things. Well, I was going to put, okay, this 18.2 centimeters. There we go. Got a radius of 18.2 centimeters. So that means our answer is going to have to be more than what? 18.2. You got a radius, an angle of 144 degrees. Well, that's nice, but 144 degrees means squat to us because we got to have it in terms of radians. So 144 degrees, we can draw a picture of it. 144 degrees is going to be where? Right in here somewhere? I guess. I'm just guessing. I'm just going to put 144 degrees and that'll get me by. So this is the area that you're measuring. Okay. So 144 degrees over 1 degrees, 180 over pi, or under pi. That goes out. 180 goes, it doesn't go out. But 2 will go in there. Pi over 90. And what is that, 72? 72 is 9 times 8, is it not? So that's 8 pi over 10, which is what? 4 pi over 5. Somebody check me. I need somebody to check me. Okay. Whatever. And then you take and you do the arc length. I don't even know what they call it. S is equal to 4 pi over 5 multiplied by 18.2 over 1. And that's going to be S is equal to 4 times 18 times 3 over 5. 4 times 3 is 12. 12 times 18. Well, 20 times 12 is going to be 240 minus. Just hold on a minute. Minus 24. I think that was it. Oh well. What's it come out to be? Around what? 12 times 18. 240. That'd be 240 minus 24, which is 216. 216 over 5 would give you 4 and 3. Somewhere around 43. Somebody check it. Why did everybody get lost? I'm just estimating right here.
I'm a little lost.
I did a little lost. I'm here.
Where did the
This is just estimating. Pi 3.14. This is just estimating. I don't use a calculator very much. Somebody multiply. See if I did my estimating right. What's 4 times 18 times 3 times 4 divided by 5? Okay, good. I got that right. Now do this, and what do you get? Do the top right here. What do you get? Okay, I can pretty much.
You have a work email.
Yeah, 4 pi times 18.2 divided by 5.
I'll use your estimation of the
We got to do 3.14. Do 3.14. 4 times 3.14 times 18.2 divided by 5. 45.7. That's the answer. I just did it in my head just so I would know if the answer was common sense correct or not. That's why I put the squiggly equal sign with the dot on top of it. That's what that means. Whatever radians, whatever it comes out to be, it should be radians. Yeah, radians. But you don't have anything in centimeters. I'm looking. Yeah, so you centimeters because it's a distance. All right, next. Oh, they're going to show us how to do it. There it is. Yeah, I figured you could. You feel good about yourself now? You don't have to look like a Oompa Loompa. Orange face and white neck. That's from some of the females. You ever seen some of those? Orange face and white neck. All right, the area of a sector of a circle. Right, this is nice to know, but it's not a real important question to ask. You're not going to see it in calculus. You're not going to see it on standardized tests, but write it down. A is equal to this area of a sector of a circle. The area is 1/2 r squared theta. And that's the area. So if you wanted to find, let's say that your property, a new highway is going to go through your property, but it's going to have a curve in it. Okay? Then they need to figure out the land that's going to be within that curve. You understand? That's the area of the land that is within that curve because they're binary. And that's why you have to have this. The area. So 1/2 r squared theta theta and radians, they're probably going to give us a question. I'm going to let y'all do it. Oh, well, they didn't. So you see how important that is. Oh, gracious, I can't believe they're showing us this. Angular speed. Now, when you start talking about speed and velocity, you're going to be using some Greek letters. Greek letters are as follows. Omega is equal to theta, which is your angle in radians, over time. The angular speed. The angular speed means per degree how fast is the thing being slung. I like everybody to think of a slingshot. Not the slingshot with the Y, okay? The slingshot David used. Yes, Goliath. Okay? That is a story. I'm not trying to convert anybody, okay? You know, the little piece of leather that's on a strap that you sling, think of that in a circle. All right? It's moving at 360 units per revolution. Okay, so if you wanted to find the angular velocity of a certain angle, how fast it's going, that's how you would find it. Y'all starting to feel intellectual now? Okay. Linear speed is defined by tau. I believe that's tau. I'm not sure. S is linear distance, which we just figured that out. S divided by time. Since the distance traveled along the circle is given, we figured that out. By the arc length, we can rewrite tau, I believe that's tau, lowercase tau, is S over T, which is R theta over T, which can be written as R theta over T, or R, which we just did, omega. R times omega. Don't worry about this. I know it seems like a lot, but we'll go over a couple of questions. It's not going to be that difficult. If they don't have us one here, we'll do some, but not today, because we're about ready to run out of time. Oh, we have run out of time, but I've already taken the roll. So all I got to do is turn off the recording and see. Now, okay, I want to stop right quick before you leave. Don't leave yet, because I know some of y'all